Now, I want to teach you how to expand. We are going to be using these rules to expand the logarithmic function that we are given, okay? Now, let's say you are asked to expand ln 3x squared, ln 3x squared all over 4z. Which rule are you going to employ? You can see that the log that we are given is a quotient, you understand? Don't forget that the quotient of a log is the difference of that log. And you know that the natural log of a over b will give us what? The natural log of a minus natural log of b. So you can easily expand this as ln 3x squared minus ln 4z. You understand? If you got this answer, you are correct. Okay, let's proceed to the next question. Let's say you are asked to expand. Let's say you are asked to expand ln x squared, okay, s cubed plus 4 all over the square root of y. Okay, now what will be the expansion of this? It's simple. You can see that we have the quotient of a log. So, and the quotient of the log is the difference of that log. So here I'm going to have the natural log of x cubed plus 4 now minus the natural log of square root of y. You understand? Okay? Now, I want you to pay attention. Don't write this. Don't say that ln x raised to the power of 3 plus. If you write this, ln x raised to the power of 3 plus ln x raised to the power of, okay, plus ln 4. This is wrong, okay? Are you paying attention? Because the sign between x raised to the power of 3 and 4 is not a product sign, you understand? So, you can leave your answer like this and you can proceed as follows. You can leave your answer like this and you can proceed as follows. Pay attention. This can be written as ln x raised to the power of 3 plus 4 minus ln. Now, square root of y can be written as y raised to the power of 1 over 2. You understand? So I'm going to have y raised to the power of 1 over 2. Are you there? Now, from the basic law that we did earlier, we know that the log of a power is the product of that power and the log. So here I can rewrite it as ln x raised to the power of 3 plus 4 minus 1 over 2 multiplied by ln y. You understand? So that is the expansion. If you have any question, let me know in the comment section. So let's proceed to the third one. See, what I'm doing revolves around all these three rules. You understand? What I'm doing revolves around all these three rules. Understanding these three rules will ease you the problem. Will help you to understand how to find the derivative. And if you understand how to expand, you can easily differentiate any logarithmic function, okay? So let's proceed to the next question. Let's say you are asked to expand ln x squared sine pi, okay, sine pi x. Okay, let me put another type of bracket here. Ln x squared sine pi x all over. I want to write the question so that you can see it very well. Let's say you are asked to expand the natural log of x squared sine pi x all over the third root of x raised to the power of 4 plus 2. Okay? So how do we find this expansion? How do we expand this? Now, it's simple, okay? Just pay attention. In expanding this function, let us take it step by step. We first have to deal with the division sign. That is the quotient, you understand? And we know that when we have the log of a quotient, that is the log of a division, you understand? The log of a quotient, like for example, log a over b will give us the difference of that log. So we are having the first sign here is quotient. So I'm going to have, you can proceed as follows. This can be written as ln x squared sine pi x, ln x squared sine pi x minus ln, okay, the third root of x raised to the power of 4, the third root of x raised to the power of 4 plus 2. Okay? Now, from this point, we can proceed as follows. Let us deal with the bracket. Let's deal with the each natural log. So do you know what I first did? I first make sure that I change the quotient to what? To negative, because according to the logarithmic rule, the log of a quotient is the difference of that log. So the difference simply means minus, you understand? So I take the differences because we have a quotient, you understand? Okay, having done that, let us deal with each natural log. Let's deal with this first. Now, what is the sign between x squared and sine pi x? The sign is a product sign. And we have been taught, we've learned that the log of a product is the sum of the log. You understand? The log of the product is the sum of the log. That is log A and B. Log AB is equal to ln A plus ln B. So we are going to apply the rules here. We have the natural log of the product of x squared sine pi x. I can rewrite it as ln x squared plus ln sine pi x, minus, now please pay attention. I want you to pay attention here. If you have the cube root, let's say you have the cube root of x, that is equals to x raised to the power of what? 1 over 3. Okay, now if you have the cube root of x squared plus 2, that is equals to x squared plus 2 raised to the power of 1 over 3. You understand? So apparently, if I add the cube root of x raised to the power of 4 plus 2, x raised to the power of 4 plus 2 can be written as x raised to the power of 4 plus 2 raised to the power of 1 over 3. You understand? So the reason why I delve into this is because I want to use it here. So for this, I'm going to have the natural log of x raised to the power of 4 plus 2 raised to the power of 1 over 3. Okay? So here, I can rewrite x squared as ln x raised to the power of 2 plus ln sine pi x minus ln x raised to the power of 4 plus 2 raised to the power of 1 over 3. See, what I'm doing is that I'm just trying to simplify this as much as possible, because if I'm able to simplify it, I'll be able to differentiate it, you understand, easily. Okay, so in an attempt to help us to ease the problem of differentiation, we simplified. Okay, and that's what I'm doing, and that's why it takes time to teach you this, because by the time you are given a complex question and you have to differentiate it, especially logarithmic differentiation, you have to be able to expand. Okay, so I'm very sure you understood it to this point. Now let's go back to our rules. You have to understand these 3 rules. See, you have to understand these 3 rules. What I'm doing revolve around them. Okay, so now look, we have the log of a power. What is the power of x here? 2. And we've been taught that ln a raised to the power of b, the log of a power is the product of that power and the log. So ln a raised to the power of b is equal to b ln a. Here, ln x raised to the power of 2 is what? 2 ln x plus ln sine pi x minus, now we have ln x squared plus 2 raised to the power of 1 over 3. That will be what? 1 over 3 multiplied by ln x raised to the power of 4 plus 2. Okay, so we are done with the expansion. You can see how useful the basic rules of logarithm is, as much as far as logarithmic differentiation is concerned. Okay, so please kindly master all the rules. Okay, kindly master all the rules. So let's say you are asked to, I want to give you one more question. So we proceed to how to find the derivative of a complex logarithmic function. Let me give you one more example. Let's say you are asked to expand. Let me take the blue marker. Let's say you are asked to expand let's say you're asked to expand y. Okay, let's say you're asked to expand, ln, let's just do like this, ln, I'm just trying to form the question here, ln cube root of x raised to the power of 10 x raised to the power of 10 multiplied by x squared plus 1, okay, multiply the cube root of x squared plus 1 all over the cube root of x, okay, the cube root of x minus 2 raised to the power of 2. How do you expand this? How do you expand this? Let's say you come across this question in exam, you have to expand this this logarithm. How do you expand it? It's simple, okay? In dealing with this question, the first step is to deal with the quotient, you understand? Okay? So here we are going to have the log of the quotient is the difference of that log, you understand? So here I'm going to have ln root of x raised to the power of 10 multiplied by, let me put a big bracket, multiplied by root of x squared plus 1. Let's put the big bracket minus ln root of x minus 2 raised to the power of 2. You understand? Okay? Now, you can see that the sign between root of x raised to the power of 10 and, okay, cube root of x raised to the power of 10 and cube root of x squared plus 1 is a product sign. And we've been taught that the log of a product is the sum of the log. Okay, so here I'm going to have the natural log of cube root of x raised to the power of 10 plus the natural log of cube root of x raised to x squared plus 1 minus the natural log of cube root of x minus 2 raised to the power of 2. Okay, now please pay attention. I want you to pay attention here. This is very important. I mean, what I want to do now is very important because I would like you to pay attention. If you have, okay, let me read this. If you have, please pay attention. If you have root of x is what? X raised to the power of 1 over 2. What if you have root of x raised to the power of 3? That is what? X raised to the power of 3 multiplied by 1 over 2, which is what? X raised to the power of 3 over 2. Okay? Now, what if you have the cube root of x raised to the power of 4? That is what? X raised to the power of 4 multiplied by 1 over 3. You understand? Because cube root means 1 over 3. Okay, I'm going to have x raised to the power of 4 over 3. Now, what if you now have the cube root of x raised to the power of 10? That is what? X raised to the power of 10 multiplied by 1 over 3. That is what? X raised to the power of 10 over 3. Okay? Now, let's go back to the question. The reason why I'm explaining this is because we are going to use this here. You understand? So, let's proceed. For this, I'm going to have the natural log of x raised to the power of 3 multiplied by, okay, x raised to the power of 10. X raised to the power of 10 multiplied by 1 over 3, okay, plus the natural log of x squared plus 1, okay, x squared plus 1 multiplied by 1 over 3 minus the natural log of x minus 2 raised to the power of 2, okay, x minus 2, please pay attention, x minus 2 raised to the power of 2 multiplied by 1 over 3, you understand? Now, for this, I'm going to have ln x raised to the power of 10 over 3, you understand? The next is power of 10 over 3 plus ln x squared plus 1 raised to the power of 1 over 3 minus ln x minus 2 raised to the power of 2, okay, x raised to the power of 2 over 3 because Do you know how I got this? Kindly pay attention. See, 10 multiplied by 1 is 10. That will be 10 over 3. 2, okay. 2 multiplied by 1 over 3 is 2 over 3. That's what? 2 over 3, you understand? Okay, so the expansion of this is, you can now rewrite it as, now, because the log of a power is the product of the power and the log. So, and we have ln x raised to the power of 10 over 3 here. I can write 10 over 3 ln x plus 1 over 3 ln x squared plus 1 minus 2 over 3 ln x minus 2. You can see that it is easy to differentiate this function compared to when it is complex. You understand? So the goals of expansion is to help us to simplify our function so as to enhance the ease of the derivative. You understand? So master this very well, okay? Because by the time we proceed to the derivative of a complex logarithmic function, you won't find it hard, okay? So